Alright, this is section 6.6, more interesting forms of the equation for a linear function, aka the line. So, hopefully you can recall from previous classes the different ways we use to represent the equation of a line. My favorite one, the slope-intercept form, is y equals to mx plus b. Yes, where m stands for the slope and b stands for the y-intercept. Good. Then we had these other forms like the slope point form from last section, and that was this, y minus y1 equals to m bracket x minus x1. Really, the slope formula moved around. M still stands for slope, but this time you have a point, and the coordinates of the point are x1, comma y1. In this section, though, we will show you two more ways to express the equation of a linear function, just because we want to confuse you even more. So linear equations can also be written in two other forms. In this case, the standard form, which is ax plus by plus c. So all the variables are on the left side. The constant is on the right-hand side. A, b, and c are integers, so we don't like fractions. And notice the constant term, like what I just said, the constant term, which is the number, is on the right-hand side. The more common one is what they call the general form, and that's this format, where all the variables and the constant is on the left-hand side. A, b, and c once again are integers, but this time there's even more restrictions. That value of a has to be positive, okay? Positive. That means bigger than 0. And in this case, it's 0 that is on the right-hand side. Okay? Now, to get these new forms, the standard form and general form, we always try to first of all find out the slope-intercept form or the slope point form. Okay? Once we get those two forms from above, then we can convert it to standard form or general form. So let's see if we can try example number 1 together. So it says find the equation of a line with a slope of 4 that passes through the point 2, 5. Do this by finding the slope-intercept form first and then converting it into general form. So remember the idea of slope-intercept form? It's y equals to mx plus b. Can anyone tell me what slope is? If you said 4, you're correct. So I'm going to replace m with 4. Now to solve for b, what I would like you to do is plug in the point. So let's plug in the point 2, 5 to solve for b. And to do that, 5 equals to 4 times 2 plus b. 4 times 2 is 8. Subtract 8 on both sides, you get b equals to -3. So therefore, the equation in slope-intercept form is y equals to 4x minus 3. And that should have been reviewed from 2 classes ago. Here's the new stuff for today. I'd like you to take this slope-intercept form and then write it in standard form and then in general form. So let's do standard form first. Standard form means you need to have all the variables on the left-hand side. So that just means that I should keep the -3 on the right-hand side. And I'll move the 4x to the left-hand side. So y minus 4x equals to -3. Sometimes the math people like putting things in order. So -4x minus y equals to -3. Let's check, are all these integers? Yes. Is the constant term on the right-hand side? Yes. Done. I'll just erase that, make it look nicer. Okay, now to go from standard now to general, remember all the terms need to be on one side. So I guess I will keep the -4x and the -y on the left side. But I'm going to move this -3 over to the right side. by adding 3 to both sides, and that gives us 0 on the right side. Now let's double check to make sure this is okay as well. General form, remember, a, b, and c are integers, you bet. 0 on the right side, you bet. But don't forget, a has to be positive. So right now the a value, which is the number in front of the x term, is not positive. We need to make it positive. How can we make it positive? Let's multiply both sides by -1. And when we do that, we get 4x plus y minus 3 equal to 0. Done. Next part says find the x-intercept of this line. Well, remember, to find the x-intercept, all we do is let y equal to 0 and solve for x. So that should be pretty straightforward. I'll use the equation in green. 4x plus, now it's 0, minus 3 equals to 0. Bring the 3 to the other side, you get 4x equals to 3. And divide both sides by 4, simple algebra, x equals to 3/4. So the x-intercept has the coordinates 3/4, 0. Done. So you ready? Let's turn the page. And now I'd like you to do the same question. See, redo the same question, but this time instead of starting with the slope-intercept form, I'd like you to start with the slope-point form. And that might be actually easier for this question because guess what? They gave you a slope and they gave you a point. So remember, the slope-point form is y minus y1 equals to m bracket x minus x1. So let's plug in the point 5 and 2. So y minus 5, x minus 2. Might be thinking, well, Mr. Lee, let's plug in the value of m too, because we know that's 4. Sure. And there you go. There's the equation in slope-point form. Now, how can we write this in standard form and then general form? Well, just like before, standard form, we have to make sure that all the variables are on the right-hand side. Sorry, variables on the left-hand side. And the constant term is on the right-hand side. I'd probably take that equation in blue and expand that out. Distribute the 4 into the bracket of x minus 2 to get 4x minus 8. And then we need to move all the variables to one side. So y take away 4x minus 5 equals to -8. Then we need to make sure the constants are on the right hand side. So y minus 4x equals to -3. And like I said, math people kind of picky, like having the x's before the y's. Done. Then, of course, to convert to general form, well, you can do it, but I'll just say see previous page, because it's exactly the same thing. Okay? So, let's try example number 2 now. It says, find the equation of a line with slope -2/3 that passes through the point -3, 9. Okay? Then write your answer in general form. And I'm going to ask you to use whichever method you want. You choose. You decide. Use what you like. Go for it. So, I guess you can do this. You can either go ahead using the slope-intercept form, which is y equals to mx plus b, or you might be one of those slope-point form people, and if that's you, try it. Y minus y1, m bracket x minus x1. So I'll give you a few minutes to try this. Okay, I will do my answer as well. But if you're listening online, stop the tape now and try the questions, and then once you're done, come back and roll the tape. Go. By the way, here, if you don't like fractions, we gotta get rid of this fraction. Multiply everything by 3. Don't forget to multiply every single term by 3. I'm just going to switch the order. Careful with the negatives. 2 negatives here. I like to, in this case, with the slope point form, let's clear the fraction. So let's multiply everything by 3 to remove the fractions. I know most of you hate fractions. This is for you. And then, of course, you move all the terms to one side. So 2x plus 3y minus 21 equals to 0. Guess I should have shown you a few more steps, eh? This is not good when I become lazy. So 3y minus 21 equals to negative 2x. Gotta add 2x to both sides, I guess. So I want all the variables and numbers on the left side so that the right side just equals to 0. Ta-da! Okay, I hope that was good. If not, come back and retry this example on your own. Ah, here's another one, example number 3. So here we've got to find the equation of a line that passes through these points. So this one says write in the slope point form and then in general form. Got some points. What's the slope? If you thought to yourself, it's time to sing that song, you bet. So you can decide which one's x1, y1, x2, y2, but that's my decision. And let's go ahead and try this. y2 is negative 1. Take away 5. 2. Take away 1. Negative 6 over 1, which is just negative 6. So now using the point slope form, we have y minus y1 equals m bracket x minus x1. Now notice we have y1, x1. There's actually 2 coordinates here. You can use whichever one you want. I'm just going to use r since I already called those y1 and x1. So y take away 5 equals to m, which is negative 6, x take away 1. Done. Then to convert to general form, of course, I'm going to ask you to please expand. So negative 6x plus 6. And then move every single term to the left side. So we'll add 6 this time first of all. So 6x plus y minus 5 equals to 6. Then I'll subtract 6 from both sides. 6x plus y minus 11. No fractions, all integers. The value in front of the x is bigger than 0. Life is good. We're done. Okay. Now I want to do a different type of question where I'm going to ask you to graph out the following equations written in standard form or general form. And this time I'm going to ask you to do this by finding both the x and y intercepts. Okay? When we're drawing lines, you only need 2 points, and sometimes it's much more beneficial or easier just to find the x and y intercepts. So how do we find these again? So just a quick review, find x-intercept by setting or letting y equals to 0. And then, of course, if I asked you to find the y-intercept, hope you remember this, set x equal to 0 and solve. So for the x-intercept, I'm going to say let's make y 0. So I have 4x minus 24 equals to 0, or 4x equals to 24, therefore x equals to 6. Done. If you want to find the y-intercept, set x equal to 0, and now go ahead and solve this. Negative 3y equals to positive 24. Divide both sides by negative 3, so y equals to 8. So in this case, here's 6, here's negative 8. Draw your line. Woo! Whoa! That's not very good. Let's see if I can move it. Woo! Woo! You get the idea. Okay? Let's make that bigger. Ha ha ha. There you go. There's A. Okay? You try B on your own. I'll do it quietly here. There you go. There are the two lines, A and B. So, very simply, instead of making an ugly table of values, just find the x and y intercepts. And then you can also connect the two dots together to find the line. Okay? So now I'm going to take a look at these two examples. And we're almost done. And I want you to graph out these equations written in standard general form by, first of all, rewriting these equations in slope-intercept form. So once again, another way of graphing out the line. This time we can take these messy, ugly equations in standard and general form and change them into our lovely slope-intercept form. How do we do that? Remember, to do that, we always want to just solve for y. So in this case, I'm going to probably move the 6x to the other side. And I'll move the 2 as well. So let's do that at the same time. So negative 2y equals to negative 6x minus 2. Once again, I want to solve for y. So in this case, I got to divide both sides by negative 2. Let's see if I can do this before my battery dies. So y equals to negative 6 over negative 2x. Negative 2 over negative 2. And once again, if you can do that in one step, you don't need to show this extra step. But there we go. How do we graph this out now? Remember, let's identify the slope, which is just 3 over 1, and the y-intercept, which is 1. So start at 1. Slope of 3 over 1 means go 1 to the right. That's the running 1. Go up 3. Connect the dots. You can do it one more time if you wish. Here's your line. There's A. We'll do B. So this one, just have to move the 4x to the other side. Becomes negative. We're dividing now both sides by negative 5. And therefore this one we get y equals to just positive 4/5 x. Now we know the slope is 4/5, but what's the y-intercept? I don't see anything. If you said 0, you are correct, because that's nothing. 0. So start at the origin. Go 4/5, so 5 to the right, 4 up. There we go. Another 5 to the right, 4 up, and there's your line. There's part B. Okay. Last example is even more weirder standard and general form equations. Part A says y equals to 6, so it's just a number. Y equals to 6. Where is the y value equal to 6? If you said here, you're correct. If you said here, you're correct. Here, 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 here. What type of line am I creating with all these points? Horizontal line. Very good. So there's your answer to A. X equals to -5. Where is x equal to -5? Right there. And here, 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 everywhere. So I'm creating another line, but this time it's a vertical line. What about C and D? Well, you might want to solve for one variable. Since there's only one variable, all the other lines had two. That's why they were slanted. So let's just go ahead and do this. 3y equals to 6. Yeah, let's move the 6 over to the right-hand side. We'll divide both sides by 3 now, and we'll get y equals to 2. Where is y equals to 2? Here, 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 here. So you bet it. Another horizontal line at the value where y equals to 2. And last but not least, 5D. 2x equals to -8. We'll divide both sides by 2. -8 divided by 2 is -4. So -4 is here. How about the red line like this? Okay. And there you have it, ladies and gentlemen. Section 6.6 in the books. Maybe this was too fast, and if it was, go back and rewind and look again. Okay, this is the beauty of doing things in video. You can listen to me as many times as you want. Once you've done that, try some of these homework questions underneath. Okay, it seems like a lot, but it's not that much, but you do need to practice. And remember, your Chapter 6 celebration of learning is coming up very, very soon. Please study.